All right, so for this video, we're going to finish off chapter 4. So in section 4.4, we'll be graphing the secant and the cosecant functions. So for the first one, secant, so similar to what we had going on with tangent and cotangent, since there is a reciprocal here, secant is the reciprocal of cosine, we've got a bunch of undefined values again. So secant is undefined, just like the tangent function was whenever cosine of x is equal to 0. And again, just like tangent, whenever cosine is 0, this happens at all of the odd multiples of pi over 2, or the way we wrote that, 2n plus 1 times pi over 2. So that was like pi halves, 3 pi halves, 5 pi halves, 7, so on, so on, so on, all the odd multiples of pi over 2. So whenever this happens, when you have an x value for your function that is one of those odd multiples, we get a vertical asymptote. So all of this looks very similar to what we wrote down for the tangent function. All right, so similarly, we're going to go ahead and graph one of these periods of the secant function. So where we're going to start on this one is actually at negative pi, and we'll just do by pi halves, and that will give us plenty of information to graph this, relatively well. And then we'll go pi halves and then up to pi. So from negative pi to pi is how we're going to graph one period of the secant function. So what we get for our y values, so for that first one, y is the secant of negative pi, which is, again, 1 over the cosine at negative pi. Well, cosine at pi, or negative pi, if you imagine we're on the x-axis over here, the cosine is negative 1 there. So what we get is 1 over negative 1, or just negative 1. And then at pi halves, again, that's the place where we're undefined. At 0, cosine is 1. So what we get is 1 there, because this is really y equals secant 0, which is equal to 1 over cosine 0, which is 1 over 1. Cosine of 0 is 1. Pi halves, again, were undefined. And then at pi, we're back down to negative 1. All right, so similar to how we approached the tangent graph, let's think about what's happening here at these asymptotes. So let's start with what happens as we approach pi over 2. That's going to be one of our first ones. So I'm going to draw an asymptote at pi over 2 and at negative pi over 2 on the graph. Now, we're going to have to be a little bit more careful this time because there's actually a little bit more to think about than what we did with the tangent case. So if we look at our unit circle, I'm just going to sketch one out over here so we can just visualize what's happening. Now, there's really two ways that we can approach pi halves. We can come at it from the right side, or we can come at it from the left side. So let's start with the case where we're coming at it from the right side on the unit circle, I mean from 0, basically. So we'll say from 0. So these would all be positive values. Okay, so we're really in quadrant 1. Quadrant 1, we have all positive x values. So as we approach it, now again, we know we're getting closer and closer to x being 0. So we know cosine of x is getting closer and closer to 0, which is no good because that's the place where we're undefined. And similar to our argument with tangent, if you're dividing by something really, really, really tiny because it's getting really close to 0, it's something very, very small, you get something very big. Now, it will be in the positive direction because, again, all of our x values here are positive. So it's a tiny number, but it is a positive, tiny, tiny number. So secant will go to positive infinity. So I'm going to draw that part on the graph. We know at 0, we were at 1. And then as we approach pi halves from 0, so from x equals 0. So as we start to get towards pi halves with our x values, our cosine gets closer to 0, which makes the whole secant function get closer to infinity, or just get bigger and bigger and bigger. Now, on the flip side of that, we're still going to approach pi halves, but this time we're going to start from pi. That means we're in the second quadrant, and these are all negative values. So what we're doing now is we're still approaching pi halves, but we're coming in from pi over here. And when we do that, every x value here is negative. So all of those are negative values. We're still getting infinitely small, but we're getting infinitely small in the net with a negative value, which makes our secant go to negative infinity. All negative values, very tiny, because that's what approaching zero means. You're getting very small. Secant gets very big, but in the negative direction. So if we start over here at negative pi, when we're at negative 1, and we approach negative pi halves, we're going to go down that wall, that asymptote. All right, so let's finish this off with the negative pi halves values. So as we approach negative pi halves, we'll say from the 0. So as we work our way towards negative pi halves, everything here is positive in terms of the x coordinate, and that's what cosine x is, right? These are the x coordinates. So everything's positive there. We're approaching 0, and because everything's positive in this quadrant, from 0 to negative pi halves, secant will be positive infinity. So if I draw that on my graph, as you work your way towards negative pi halves as your end goal, starting at 0, you blow up to infinity. Now, as you work your way to negative pi halves, but starting from pi, so now you're here working your way towards it. So as you start from pi and get towards negative pi halves, all of your x coordinates are negative. So these are all negative values. Cosine x is getting tiny, but negative tiny. And negative tiny means negative infinity for the secant function. So now as you start at pi and you work your way towards oh my gosh, I just realized what I did. I'm so sorry. I mixed those up. I meant to do this the first time. We were starting at pi, working our way to pi halves, and we went down to negative infinity. Now what we were doing is we were approaching negative pi halves and approaching negative infinity. So sorry, when I was explaining that on the graph, I kind of mixed these two up. So sorry about that if that was confusing. But yeah, in both cases though, as we start at pi and work towards a pi halves, we go to negative infinity. As we start at 0 and work our way towards one of the pi halves, in either direction, we go to positive infinity. It all comes back to that unit circle, what quadrant you're in. Are your x values positive or are they negative? So that actually is one period from negative pi to pi. So 2 pi is our period for the secant function. Or more generally, if it's a secant of bx, then our period would be 2 pi over b. Okay, domain and range. Now, domain is the same as it was for tangent. So it's x such that x is not a odd multiple of pi over 2, as long as it's not one of those pi over 2s. Our range is not like tangent. It doesn't include all the y values, because if you look at the way that this, if it was to start to repeat itself at -3 and +3, you'd have all these u's that would look like that. You're never actually going to hit any of the y values between 1 and -1. So what we can't, a couple ways to say that: y is greater than or equal to 1, or it's less than or equal to -1. Another option, you can write it with absolute value and say the absolute value of y is always greater than 1, greater than or equal to 1. So it does equal 1 and it equals -1, but it's never going to hit a value in between those two when you go to graph it. Okay, and then it would just keep repeating. That's our one period from negative pi to pi, and then it just starts over. All right, so by very similar argument again, we can talk about the cosecant function in the same way. So cosecant is 1 over sine x, so it's undefined when sine x is 0, and sine is 0 at all of the integer multiples of pi, or n times pi. All right, so we'll graph one period similar to where we started with the cotangent. We started at 0. We're going to do that again, and then we'll go by pi halves. And this should cover one full period. So let's see what we get. So if we plug in y equals the cosecant of 0. That's really 1 over the sine at 0, which is no good because sine at 0 is 0. You can't divide by 0. You get undefined. At pi halves, sine is 1, so we're going to get 1 here. At pi, we are back to a problem area, every multiple of pi, every integer multiple of pi. And then at 3 pi halves, sine is negative 1. So is cosecant. 1 over negative 1 would still be negative 1. And then we're back to another asymptote at 2 pi. All right. So it's going to look pretty similar to what we did with the secant function. So we'll start here at 0. We'll have pi halves, pi, 3 pi halves, 2 pi. And at 0, we're undefined, so that's one of our asymptotes. At pi, no good. And at 2 pi, no good. And we'll draw one period here. So at pi halves, we're up here at 1. And then at 3 pi halves, we're down at negative 1. And very similarly, as we get closer and closer to 0, all of our x values are positive here. So we're going to get a thing that looks like this. And then from pi halves to pi, so now on the unit circle, we're thinking about the y values. So y is positive up here, right? So as you make your way towards pi, all of your y values are still positive. And remember, sine is the y value. So everything's positive there. And then you flip that, everything is negative, because now we're looking at pi to 2 pi, where y is less than 0 on pi to 2 pi. Looks like that. All right, so our domain is going to be similar to how cotangent was. It's all the x values such that x is not an integer multiple of pi. Same range as secant, and same period. If we're looking at this, our period is 2 pi over b. All right, so it went from 0 to 2 pi, and that's our period. All right. One quick example, and that will be the last thing I do for this video. So we're going to graph 3 secant of 1/2 x. So first thing to note is it has that stretch to it by a factor of 3, kind of like an amplitude, but there is no max, there is no min, so it's not exactly an amplitude, but it will stretch it out to 3. So instead of starting at 1, we'll be starting at 3. And then this tells us that our period is going to be 2 pi divided by 1/2, or 4 pi. So we've actually doubled our period, and we're going to make this a much wider graph this time. All right, so if we're going from 0 to 4 pi, our period is 4 pi, but where we're actually going to start is at, negative pi. So we'll still start at negative pi. I'm going to go to 0, pi, 2 pi, and 3 pi. So we've really stretched this out. So we're going to start at negative pi, and we're going to end at 3 pi actually this time. So we're doubling that period. So at negative pi, we're looking at 3 secant of negative pi over 2. And secant is 1 over cosine. That's no good. That's an undefined value. At 0, we're looking at 3. Pi, we should be back to an undefined value. At 2 pi, we're looking at negative 3, and then back to undefined. All right, so we've got negative pi, 0, pi, 2 pi, 3 pi, and our asymptotes, pi's, and now we just want to be at 3 and at negative 3. And we'll look something like that.